Good day, grade 8s. So we're just going to be working through exponential equations today. First thing we just need to keep in mind is what an exponential equation is. Obviously it's an equation, so we have an expression equal to an expression. But more specifically, what makes it unique from just normal equations is that our variable is in the exponent. Okay, so we're going to be solving for x, but it could be any variable, of course. And this is just going through some of the techniques that you need to be able to answer these questions. Okay, so let me just get a nice color pen. Okay, so firstly here, we see we have 5 as our base on the side. We want our bases to be the same, and we want them preferably to be prime numbers. So 5 is already a prime number, so we need to go think, okay, 25. Can we rewrite 25 to have 5 as a base? And of course we can. It's 5 squared because it's 5 times 5. So we go rewrite. That's supposed to be 2. Our 25 we rewrite as 5 squared. Then we know, okay, now currently our bases are the same, meaning for the equation, for the left-hand side and the right-hand side to be equal, that means that our exponents are also equal. So 2x is equal to 2, and our goal is still to find x. So therefore we just go, so 2 times x is 2. If you just see it's 1, you write 1. If you just need a bit more, divide by 2 on both sides. So x is 1. We of course don't have to write that last part if you just find it from inspection. Okay, second technique, and this pops up every year, everywhere. 1. So we know from our laws of exponent, there's this special, more of a property than a law, but yeah, anything to the power 0 is 1. So when we're working with exponential equations, this technique needs to be in your back pocket. We are going to manipulate 1 to have whatever base we wanted to have, just with an exponent of 0. So in this case, we have a 3 there. So we want this base also to be 3. So we can do that by just writing 3 to the power 0. Now again, bases are equal, therefore our exponents are equal. So 2x is equal to 0, meaning x is 0, or you go divide by 2 on both sides and find that x is 0. Okay. Last technique that we'll be looking at today, and I'm going to show you 2 different ways you could answer a question like this, depending on whether this number here in front is the same base as the number at the back, or that it's being multiplied with. If it differs, we're going to have to do the second method, but we'll get to that in a moment. So this question says 3 times 3 to the power x is equal to 27. So already we know 27, we want 3 to be the base, and we can rewrite it. So that would be 3 to the power 3. Then on this side, we have 2 bases that are being multiplied, with that exponent being 1. That's a very ugly one. Let's see if we can make it a nice one. Ooh. Okay. Even worse. Anyway, now we are multiplying same bases, therefore we add exponents. So that will be x plus 1 or 1 plus x, same thing. Commutativity law, of course. Then we now see, okay, same bases, meaning x plus 1 is 3. Okay, but we only want x. We don't want the answer for x plus 1. So this plus 1 needs to move to the other side, and we do that by using the inverse operation, of course. So we're going to subtract 1 on both sides so that we can get x is equal to, x is equal to 2. Okay. Alternatively, and this is especially useful if this number does not have the same base or cannot be written with the same base as this one, then you can say, okay, I'm just going to quickly rewrite the question here next to it. We want to find the x, so the x is there by the second 3. Whoops, what on earth did I just do? Oops, okay. we want this second one. So we divide by 3 on both sides, so with the reason so that they can become 1, so that we have 3 to the power x, 3 to the power x is equal to 9, which we know is 3 squared. Again, same basis, so exponents are equal, and then you get to the same answer. Okay, so it doesn't really matter which one you use when the basis of the two products are the same. If they are not, however, you are going to have to use the second method. Okay, have a good day further.